All right, so this is our last official lecture class for the course. So thanks everybody for a great semester. We have a couple more things left to do. So today is Cogen 3 is due. We'll have office hours after this if you have questions about that. But remember, you have plenty of time to resubmit. Yeah.
I wanted to come to the office hours this morning, but it was canceled, and I have a lecture after this one.
So we can, this semester, I think I'm going to ask him to do is just do like mass regrading, because this is kind of easier. So by like Friday or something, he'll just like do mass. I'm going to ask him to do mass regrading. Yeah. But sorry, does that answer your question?
Yes.
Okay.
Will it submit those homework assignments late?
No, homework assignments aren't. There's no late policy of the homeworks. We go over them in class. But they're not graded for correctness, so you could like submit something reasonable. Now, with all grading, let me know at the end of the semester if you have any issues with the grade. Remember, 5 of them are dropped. I think it's 5. Yeah, only 20 of the homeworks count. There's 25 of them, so 5 of them are dropped. And then, if you're like literally between grades, one homework is going to count for, I think, 1% of your grade. So I try to design this so like any, little mistakes or picadillos are going to not kill your letter grade, but let me know at the end of the semester. I'm going to have ample office hours next week. Does that answer your question? And if you had an excused absence, like you were sick or you're on a university trip, just let us know on EdSTEM and we'll waive the grade. Yeah?
Just a heads up, it's only 4 because I think we skipped one.
Oh yeah, you're right. It's 24. You're right. That's why I wrote it like this, because I didn't want to have to calculate how many are dropped. But yeah, these are numbered. You're exactly right. So these are numbered after the lecture number. It's really annoying to try to do name spacing, proper name spacing here. But you're right. There are 24. 4 are dropped. Thank you. You had a question?
Do you know how many questions are on the exam?
Yes, I will go over the exam. I'll go over the number of questions and
How many
time.
questions do we get notes to bring?
It's 12. So this is on the. So I'll go over the full exam in a sec. But
It's just 4 homeworks that get dropped and nothing else gets dropped, right?
right, nothing else gets dropped. Instead, for the gross that's graded for correctness, you have regrade opportunities, resubmission opportunities. Yeah.
I could be correct, you could be talking, discussing a little later, answering the question, but is this final exam cumulative, or is it?
Yes, it's cumulative. It'll be like roughly 40, 60. I think I'll show the breakdown as well. All right, I guess we're ready. Oh yeah, okay, yeah.
We get
12 pages
12 pages
of notes?
of, 12 pages.
Front and back?
Front, 24 sides total, 12 pages total, yeah.
Okay.
Yeah. Other questions before going on to the final? There's no homework today, so there's no homework to go over. Other questions on projects? Yeah, I know the project's due tonight. Apologies for the office hours today. I will still have office hours afterwards. And remember, you can submit or resubmit after the deadline. And if you have a good reason, like, hey, that 1 point should be taken off, let me know, and we'll talk about it in final grade. I doubt any few penalties from missing homework or missing attendance or having a resubmission are going to hurt your grade. But if they do, let me know, because that's the way I designed the course, so that little timing, you won't be measured on punctuality and exactness all the time. It's like either or. Yeah. Oh, okay. So yeah, let me go over that let me make sure these are up to date with my calendar. So I put on here my office hours, my final week office hours. Let me make sure these are up to date with my schedule, because I was tweaking this. Tuesday at 12, Thursday at 12, which is going to be after the exam. So the exam is not going to be 3 hours, it's going to be 2 hours. Don't worry, you'll still have plenty of time. I've also removed open-ended, it's all multiple choice. There'll be 2 hours for that. It'll be right after the exam, and then I'll have a longer office hours on Friday. So everything, all grading for the class, like all grading, assignments and exams, should be finished by the end of day 1204, and then we expect to have your final grades on Friday, so that you can come to office hours, and if you had any issues with your grade or you want to see your final exam, we can go over all that grading stuff here on Friday. Now, please ask for regrades before that. We still have, almost 2 weeks 2 weeks of business days, not counting the holidays, of regrading. But yeah, this is the schedule for next week. So we don't have class Tuesday and Thursday. We have exam at 10 a.m. instead. So I made my office hours at noon Tuesday and Thursday, and then one hopefully final set of office hours on Friday for any last minute issues you have. You want to look at your final grade, talk about your final grade. Yeah, does that answer your question? Other questions on before I get into the final? Yeah.
So you said our finals at 10?
The final is at 10. So this is dictated by the university scheduling. So there's like a where is this? I think you know this, right? For other courses, this is what I go by. I assume this is how they do it. I think they just use the same room, and then they have to schedule around people who are like in the same room. They schedule like 3 hours almost for everyone. So we're Tuesday, Thursday at 12, I think, ending at 1:15. So this system just commands me to have office hours at 10 a.m. to 12:50. But in the past, I won't take this whole time because I don't want to subject you to a 3-hour test. So I've made this 10 to 12, and then I have office hours at 12. But the exam is not a 3-hour exam. It has 32 questions. You have 2 hours for 32 multiple choice questions to cut to the chase, which is like however much that is, like 4 minutes a question or something. Yeah. It'll be the same scheme as the midterm. It'll be on web courses. I'll print out some paper ones. If you're doing with SAS, it'll be on paper because of the issues with timing with that. But yeah, so it'll be here with your laptop. But it'll be all multiple choice this time, so it'll make mechanically a little bit easier. Not necessarily an easier exam, but it'll you won't have issues with that box. When you click on the box, it just like disappeared or something. So people have this problem with web courses. But yeah, so that's the final exam. So let me make sure you have the information here. So yeah, okay. So I didn't have this up to date until yesterday, but this is the final. Thursday, 12:04. I mean, it was on here. It was down here before. 12:04, 10 to 12. So this is the final exam day and date and time. It'll be in this class. Yeah.
I know the fourth is the last day to submit the assignments. Is it also at 10 or is it like at midnight?
No, it's at midnight. So yeah, that is a good question. I kind of left it here to due on the date and the schedule at the end of day local time. But yeah, no, it's not due by the final. It's due by that night. So that's why I had office hours afterwards and then do that night. So that way, after the exam, you'll still have time to do resubmissions, come to office hours, still submit your project. It may not be regraded by that time, but yeah, we'll regrade it the next day, and then hopefully you'll have everything squared away by that time. But I'll still have office hours on Friday after all the deadlines. Yeah.
I'm not really on time, but how do you access the feedback?
This, yeah, sure. So this is described here in the first project. Yeah, if you go to the feedback repo section, I know this is a long time ago and maybe you forgot about setting it up, but it tells you in here. So as long as you set this up during this assignment, you can just go into your feedback folder and type git pull, and it'll pull. So our scripts will grade your software and then create the report and push it to your feedback repo. If this doesn't work, it may be that you didn't set up a feedback repo, and then you won't get feedback. Yeah.
I have a question about question 3.
Yeah.
On STEM, you said I should try diff to see the difference between the example output
Yeah.
and my output. And I did that, and the only differences were comments and tabs. So that should be white space, right? It shouldn't cause the compilation error.
Shouldn't. If you have a second after class, we can look at it. Let's look at it briefly after class. Because I saw other people have this error as well. You get it says like assembly junk after some command or something. But so make sure you have the .s file. If you have that, then let's look at it and see why it's complaining. Because I thought it might be broken syntax in ASM, but if it's looking almost exact, then yeah. Let's take a look at it after the class. Other questions? Besides final, I'll go over the final. Yeah.
I was just going to ask, so the final goal multiple choice?
Yes. So, all right. Shall we go over the final? Everybody ready for the final? Oh, yeah. We got to do as threatened and promised. Because somebody asked about it, are we doing attendance? I didn't even think of it because this is technically, there's classes this day. Now, for people who are like watching remotely and sad they're not getting their attendance, remember the attendance is literally 4 divided by 25 or whatever it is. That's how much you're losing by missing one attendance. And you still get a bonus if you're over 75%. So, is there another, question?
It's some of the final can be online,
The stuff for the final?
like all the information we're looking for.
Yes. Yeah, so this is all, so I've updated this now where this final review, I now have notes for this lecture. This has all of the format, location, date and time, format of the test, the materials that we're going to cover, or that could be covered. That's all here now on the schedule as part of the notes for today's lecture. All right, so let's do attendance. Okay, let's go over the final exam. So just, as reminders, it's going to be next Thursday. That is the week after this Thursday. This Thursday is Thanksgiving. So it'll be Thursday, that's December 4th, 2025. And it'll start at 10 a.m. and end at 12. Actually, it's going to end at like 12:05. So you're going to get 2 hours, 2 full hours to work on this exam. It'll be here in the lecture room, this room right here, HEC 125. And, this is wrong, sorry. It's actually 32. I made an error here. Apologies for that. It's actually 32 questions. I was trying to make things nice, round numbers, so it's like 12 points, whatever it is. Actually, it's not a nice round number, but it's going to be 32 questions. The whole thing is worth 12 points, 12% of your grade. A little under half. What percentage is that? I don't feel like doing math in my head. So yeah, like 44% is midterm stuff, and the rest is stuff after the midterm. So the midterm stuff is all review, so they're questions that you should have seen before, similar questions like from homework, except I don't think I put anything on build systems on there. And then the second half is on, what we learned in the second half, the compiler stuff. So the source to process tool chain, a lot on x86, how do you implement functions, how do you implement addition, stuff like that. How do you translate simple IR, looking at assembly and understanding what it does. So that's what the second half material is on. It's largely on compilation stuff. Now it's 32. Questions on the format? So it'll be, let me actually get the final exam. I'll put this up as well. This is what will show the kind of rules during the class. Let me show this as well. Post this up here. There we go. So it's very much like the midterm, except you have got 2 hours to complete it. Unless you're an SAS or you had an excuse, you got to be in the exam room here physically. We're going to use UCF here to record your attendance, or let me know as usual. Submit your exam on time before leaving the room. Show your UCF ID to us, the instructional staff. To submit your exam, you'll submit it either online or physically. Show your ID card, show your notes. You don't need to. You can keep your notes. Don't take the question sheet if you're taking it on paper. I know it's impossible to sit one seat apart, but we'll have you come in, sit near the front, separate you as best as we can. Only have this stuff on your desk. Your 12 pages of notes. Remember, it is 12 pages of notes that you can bring. Those are 2 sides, so 24 sides of pages. You can bring scratch paper. And your exam, which is either your laptop with the exam only open, don't go to any other applications or sites, or your question and answer sheet with the writing utensil. If you have scratch paper, you can also bring your writing utensil. Prohibited are any devices for unauthorized information or communication devices. This includes, pencils that have information on them, so that's why I put this here. Some of this might be cell phones, mechanical devices, information sources, electronic devices, anything else on your laptop. So really broad, just basically this is your white list or your allow list. This is your block list. Your block list is the whole universe of things. The white list is just these things. And then follow university policy. SAS students, we'll upload it. We'll do it like we did before. If you have any questions about SAS, let me know. Raise your hand. Stop taking the test before the exam period ends. So same kind of format as last time. Little, maybe strange format, but it makes grading easier, makes grading faster, less paper. Questions on the exam logistics? Yeah.
So it didn't happen with the midterm, but I know when I walked out, I opened my phone and I checked to see if my grade was already there, and Canvas yelled at me that it created another exam section. Is that something that it's going to do for this?
It might. I mean, there's just like a setting where you say don't allow multiple sessions.
Okay.
So, I mean, we didn't like penalize anybody last time for doing that.
Okay.
It'll notify us, but we didn't like penalize anybody for doing that. That's okay. And this time, actually, you should get your exam score right away after you submit it because I'm going to do all multiple choice this time to save you guys a little bit, maybe, but really to save my grades, to save my GTAs because I just have GTAs, not graders this semester, and so I can get the grades out really fast to you guys. That said, I used to work for that evil corporation, ETS, who makes exams that torture students, so I use some of those tricks in my multiple choice, which some of you might have noticed in the last exam. So it's not always easier to have multiple choice. So I did tried to make it a little bit, hard to guess, basically, on the exam. But yeah, you should get your grades, accurate grades, like right away after you submit. Other questions on logistics? And that evil corporation thing, that was just a tongue-in-cheek. I love ETS. It's a great company to work for. Any other questions on logistics? All right. So this is just going to be kind of an open review. I finally made the exam. I actually finished it this morning. So I'll actually get it open and make sure I don't lie about any of the content on the exam. So do you want to go over the cumulative stuff first or the new stuff? The new stuff. All right, let's go over the new stuff first. So that's the procedural stuff and it's question topics. So, all right. So second half material. No source code to processes. So at least we went over this at a pretty high level. But you should have at least some sense of what each of these stages do. So I guess first off, which hopefully everyone knows this now, if you take a C program and you give it to an Intel processor, is it going to run as you expect? No, right? Why not? What's the encoding of the C file and what's the encoding of assembly or machine code? Yeah.
They're completely different.
Yeah, one is just ASCII text, which has no computational meaning on its own or according to any process instruction set architecture of any processor. So if you just try to pass that, the processor is going to try to interpret the binary code for ASCII as x86 instructions. There's no way it's going to run as x86 instructions. So that's what this tool chain does. It takes source code, which is a programming language that doesn't get interpreted by any machine on its own, or doesn't get interpreted on its own by an Intel machine. Instead, it goes through several stages of translation and processing. So preprocessor, we didn't talk too much about preprocessor. Preprocessor just does macros, headers, conditional compilation. Compiler, what does the compiler do? Any takers? What is its input and output? I mean, it is here on the screen. Here on the screen. Yeah.
The compiler is the part that takes the C and then reproduces it in assembly?
Yeah, that's exactly it. It translates between the two. So it doesn't necessarily make an executable. It doesn't run the program. It just translates between two languages, typically a high-level language, low-level language, in this case C and assembly. And while the assembler and linker and all the other parts needed to make an executable program is bundled with GCC and typical compilers, it's not, strictly speaking, the compiler. The assembler is what takes, and modern compilers will just go directly to machine code. They will not bother necessarily with making a text assembly file. but to be pedantic, the assembler will take assembly text, turn it into machine code. And is this .object file executable at this point? No, right? What makes it executable? The linker, and do you remember what it adds or what it links with to make it executable? Was that?
The main,
Was that?
the main.
It's close to the main, so you provide the main. But there's this C runtime, which we didn't talk too much about, but it's basically snippets of assembly code that will call main for you. And then the loader will run will basically branch to your _start label. That's kind of system defined, but that's the default in the Linux world. Yeah?
To clarify, functions in a piece of the object file?
Yeah, effectively you can think of object files as having a set of functions, a set of symbols, which are functions and variables, and the linker will take two object files, turn them into one object file, and make sure all the calls, callees and callees match up. Yeah.
How much in-depth do you need to know about each of these processes?
About what I just said. So if you understand that the linker merges multiple object files and lines up callers and callees, if you know that the assembler translates assembly text to machine code, which is in the object file, you know that C compiler translates C to assembly, that's about the level you need for the exam. Because we didn't go much deeper than that. I just sort of illustrated it to you. But for some of you, that may be more than you realized before this class, right? You may not have understood why you had to run a compiler first, right? Or why you have to run a step first before you run. So for this class, that's sufficient. If you're interested in more, take compilers. I often teach it. It's a grad course. But yeah, that's sufficient for this part of the class. Other questions on that? Okay, so then the rest of it is really just knowing simple IR and assembly code and how to translate between the two. I may ask you some questions about looking at assembly code and figuring out simple IR, or looking at even C code and writing simple IR with multiple choice. So understanding translations back and forth, so compilation and decompilation between the two. So if you did the project, that shouldn't be too tough to do. They're not going to be like super long programs or anything. All right, let me take a look at the questions. Any other questions on these topics right now or on the format of the exam? Yeah.
Would the exam be perfectly split in half between old content and new content?
No, it's like 40-60. So it's 14 old content, 18 new content. So it's split between the two. So the old ones are mostly not new, or mostly not old questions, but sort of variations for the most part on old stuff. So yeah, it's a good portion of the exam that is on old stuff. All right, I guess I'll just go over it. So let's start with arithmetic. What assembly instructions perform arithmetic? Or what are some of them, the ones we used for our class? Yeah, what's that? Add, sub, imul, idiv. Remember it's idiv. Because there's also floating point division. Idiv is integer division. I think that's what it was, right? But you don't have to know that little detail. Being able to write assembly code. So if I give you, here's x equals x divided by 7, the stuff from here. So if we give you some simple IR snippets of code, and we'll give you symbol tables as well if you need them. It's like this. So we'll give you like symbol table, we'll give you simple IR code and say, all right, what is an equivalent assembly program according to our semantics in this class? So and then you'll write, or you won't have to write it, it's multiple choice, you'll have to pick the one that's equivalent. So it can be for addition, multiplication, subtraction. You also may have to look at assembly code like this and say, well, what simple IR program is most likely to have generated this code? That's decompilation. And so if you understand enough about what the assembly code looks like from simple IR, if you did the compiler projects, that shouldn't be too hard to do. Questions about that? Thoughts about that? Yeah.
Just to clarify, you did say we won't be needing a table itself for the
Oh, yeah, no, I'll give you the simple table. I'll give you the simple table. So, because this is kind of compiler dependent, how memory is laid out for local variables. So I'll give you a simple table when you need it in order to know offsets. And why do we need to know offsets? How do you access variables? What's that? Well, you do need it for dereferencing, but you also need them just for, even for addition, for referencing, yeah.
Don't you access them using the offset with percentage RBP?
Yeah, that's right. So that's what the symbol table is used for, because it's what how the compiler laid out the memory for those local variables. And that is kind of compiler dependent. That's not really, the API reserves that space, or allows compilers to reserve that space, but the compiler can decide where to put local variables. It doesn't even have to use local variables if it doesn't want to. It can use registers. But for our compiler, we stored everything in this laid out in memory offsets from RBP according to a table. And I'll give you that table if you need it for compilation or decompilation. So that's a quick review of arithmetic. Any other questions on arithmetic? For arithmetic, it was pretty formulaic. So hopefully, if you did the project, hopefully you saw that it was not too bad to translate between the two. Branching, similar story. So you'll get something like, or you may get something like, here's a snippet of simple IR. What would its assembly look like? And it's multiple choice, so you can just pick the one that's the best one. So this is an example of, so some of these answers are going to be pretty long because it's going to be like, 10, 20 lines of assembly for a few lines of simple IR. But just pick the one that, best fits or is equivalent to the simple IR, and vice versa. So you might get, say, this is a easy one, but if you get label in assembly, what's the simple IR equivalent in assembly? Or some other assembly code. Questions on this? That's branching. Do you like any reviews of branching?
Like, question with the branching, when it comes to saying giving us the snippet of code, like, how big is the snippet? Is like just a small, just a quick look.
Let me take a look. So for the simple IR, for translation stuff, okay, good. You can't see that on screen because I'm looking at the exam. For translation stuff, let me see. I have one that's 7 lines of simple IR in here. Let me see if that's the longest. I have a 7-line. I think that's about the longest. So nothing too substantial. Most of the exercises in this class, like the largest one maybe was like the Fibonacci one, but they're not huge ones. Now, some of the assembly can get longer. So some of the assembly answers might be like, I don't know, 10, maybe 20 lines of assembly. So, but remember, the assembly is much more verbose because it's like one instruction at a time. So if you can just, kind of recognize the patterns a little bit from the simple IR, that'll help you see what's going on. There are simple IR programs that are longer on it, but they're not for translation exercises that I can see. Does that answer your question? So they're not huge. So it's not designed to kill you. So 32 questions, 2 hours. That's 4 minutes a question or so, 3.5 minutes a question. Other questions on branching? So just be aware of the code. If you did all the codegen stuff and you went over the exercise, it should be hopefully pretty familiar. These are the different opcodes. Remember, yeah. Any other questions on branching? So yeah, just remember the different opcodes for them, the conditional versus unconditional branches in assembly, same in simple IR, conditional versus unconditional. This is conditional, corresponds to one of the conditional branches in the x86 world. Labels are the same. Unconditional branches are like this in assembly, yeah.
So, looking at this review, where you're not gonna be touching anything related to stack smashing or functions?
Oh, no, we're gonna go over functions too, yeah. That's next. No, there'll definitely be functions on it. That's like,
I didn't see oh, it said functions, okay. I didn't read that.
yeah, sorry, I put it, it's kind of in the wrong order, but, yeah, it's here.
Okay.
Yeah, I didn't go over that yet. That's actually what we did last. In fact, let me update this. Other questions on branching? Everybody good on branching? And there, I moved it. All right, then pointers. Pointers is one of the more confusing ones, I think. Hopefully, I think everyone has a little better understanding of pointers after actually like seeing how they work at the assembly level. But yeah, some of the assembly is a little confusing when dealing with pointers. So, but just remember, there's only a few operations for pointers. There's the where is this? So it's in here somewhere, but just trying to find it. But you have where is it? You have just register copy without the parentheses, and then you have like indirect register loads and stores. So this is an indirect. So this instruction here, what register holds the address that we're loading, or are we storing or loading, and what register holds the address for this instruction? So are we doing a store to memory or a load from memory here? Load, right? It's a load because, AT&T syntax, destination's on the right. Which register holds the address of that load? RAX, that's right, RAX. So the parentheses say, look up this address at the register. And so if you swap these, if you put the parentheses on the destination argument, then it'll be a store into memory. And then without parentheses, it's neither. And so actually these, whenever we did variables, we were actually doing this register indirect addressing the whole time, even though we didn't think of it that way. And so, just distinguish in your head the variable loads and stores from the pointer operations. So this is like a pointer operation. If you see parentheses, you're going to do some sort of pointer operation, either a dereference load or a dereference store. And then for reference, remember, how did we compute the address when we took a reference like this of a variable? How did we compute that address? So we took RBP and just copied it to a register and then added its offset to it. So if you see any code that's doing something like this, where it's copying RBP and then doing some computation on it, we're working with the address of a variable in that case. Whereas with references and dereferences, we're using this register indirect load and store. And there's the store, register indirect store. Questions on pointers? Yeah.
So the indirect, that basically just tells it to look at the memory stored in RAX?
Yeah, either load or store to this the address that's stored in RAX.
Okay, so it wouldn't store the value, then it just stores.
Well, this one is a store, so this one is storing the value that's in RBX into the address given by RAX.
Okay.
For the reverse one, what you're saying is right. So for the reverse, which is here, yeah, this is not copying the value RAX into RBX, bless you. This is copying the value at the memory address given by RAX and storing that, loading that into RBX. So a little different from MIPS. I think MIPS has separate instructions for this. x86 world, CISC has one opcode in assembly for many, many different operations. So you just have to look at the arguments to see which is which. Other questions on pointers? Was pointers hard? You think compiling pointers, was that stuff hard? That was easy? Just following the patterns? Okay. Other questions on pointers? All right, then probably the hardest one, functions. So for functions, let me look at the exam here. So yeah, stack frame. Stack frame's an important one. So what information is stored in the stack frame? So are parameters stored in the stack frame? Some of them, good. So all this is going to be the System 5, AMD 64 ABI, the one we learned in class. What's that? So the calls themselves are like an opcode, right? So what about the call is stored there? Not necessarily, not the calls. The parameters are stored. So how many parameters are stored in registers? How many are stored in the stack? So yeah, 6 in registers, all the rest in the stack. Who stores the parameters, the caller or the callee? Remember, the caller is the one making the call. Callee is being called. Parameters, yeah. So is it caller or callee stores parameters? What's that? Caller. So remember, the caller is the one making the call, so it has access to the parameters. So, because they're from its local variables, so it can store those in memory or in registers. So caller does parameters. What else is stored onto the stack? So let me get the return address is stored onto the stack. Who stores that? The caller or the callee? The caller. Good. Yeah. Let me get the diagram up to follow help make this clear. So in green here, before the new RBP, this is what the caller stores. The caller stores the parameters, any ones after 6, and then the return address. Now, what else is stored onto the stack? What's that? So what's RBP? Or what? Base pointer, yeah. So what's the base pointer? What's the purpose of the base pointer? Well, it's not the current address you're executing. So what's that? The current address that the processor is executing. What register is that stored in? Our IP, yeah. SP is the stack pointer. So RSP, RBP, these are for data, the stack specifically. And the RIP is pointing into the text segment, the part that stores the machine code that's being executed. So RBP is pointing at the stack frame informally, at the currently executing function stack frame. Sometimes it's called an activation record, a record of the currently active function. But in the actual ABI, it's pointing at the address of the old functions, the caller functions base pointer. So if you remember from how our function calls work, after the caller makes the call, saves the return address, and goes into the callee, the function being called, the first thing it does is it saves the old functions, the calling functions base pointer, pushes that onto the stack. That's the callee that saves that. And then it updates the base pointer, so now that we're pointing at the current function's stack frame. All right, then what else is stored on the stack, typically, at least in our compiler? Local variables, yeah. Anything else, or at least that we talked about in this class, that's stored on the stack? Pretty sure I have questions about this. Let me find them. Yeah, anything else on the stack in our compiler? Nothing, right? Just those 4 pieces for our compiler. Any questions on that stack frame stuff? So remember the stack frame, the purpose of the stack frame is to freeze the state of a currently executing function so that if we have a nested call, we can hold on to the state of the current function. The current function tells us where to get local variables, where to get parameters, where to return when the function's done, where to access the calling function stack frame. All that gets saved onto the stack, so when we make another function call, a new stack frame is created for that function call, and so on until we start returning from these functions. Just looking at the exam questions. All right, any other questions on stack frame? Let's look at more details of function calls. Say how are parameters passed, we said that. How are variables, how's the stack frame managed? Prologue and epilogue, how are values returned from a function? Okay, so how are values returned from functions? Does the ret opcode return a value to the calling function? No, right? What does the return opcode in the x86 or AMD 64 instruction set do? What does it do?
It like freeze, right?
It what?
Doesn't it freeze? Doesn't it like add everything back after subtracting?
Not everything. So it does pop from the stack. What does it pop off the stack?
Isn't all the local variables not the return value?
So that's what our code will do. But the ret opcode itself. So our simple IR return instruction will generate code that cleans up the stack. The return won't do that actually, but the end function will do that. But the return itself, so there's two questions here. One is, what does the return opcode do, the ret opcode? The ret opcode, we might as well look at them together. So the call opcode, not the simple IR statement, but the call opcode pushes the return address onto the stack and branches to whatever label you give it. Ret does the reverse. It pops the return address off the stack and then branches to that address. That's all the x86 or AMD 64 opcodes do. They don't do any of the function stuff that we expect in C or simple IR. They don't handle local variables. They don't do return values. They don't do parameters. They do none of that. All they do is save and restore the return address and branch between the two caller and callee functions. That's it. It's the code that you generated with your compiler that simulates these C-like functions in our simple IR language. Okay, so that's what the ret does, that's what call does, the opcodes do. What about the return? Yeah,
Can you
go
show
ahead.
real quick, if you have time, the code between the ret, going back?
Like the assembly code?
Yeah, the ret.
Yeah, like an example of using ret. Sure. Yeah. Let's look at an example. So here's, I think this is a good example of the stack frame setup. So this is return. Notice it comes after popping RBP. It comes after cleaning up the stack. Okay, here's a complete example. So this is a complete example of a simple IR program. This is what end function does. End function just generates code, if you remember from CodeGen 3, that cleans up the stack, that is, it removes local variables, and then restores the base pointer by popping it off the stack. So recall, oh sorry, it's not here. Let me get the picture of the stack frame. So if RBP is pointing here, RSP is pointing here, then when we add to RSP, we remove these variables from the stack. Now this says 16 and there are actually 24 bytes here, but your compiler will generate a subtraction or an addition that will clean up all the local variables. Now our stack pointer is here, and we pop RBP off the stack. That is, we pop whatever this value is and save it into RBP. That's going to restore RBP to be the stack frame of the caller. Once that's done, then what's left on the stack? The return address is the top of the stack after we pop this off. So when we call the return opcode, return is going to pop that off the stack and then update the branch to that address, update the RIP to that address. And now we're back into the caller. What's that?
The clean stack for the next code?
Well, it's almost. So we're back into the caller, but the caller will clean up its local parameter, the parameters that it pushed on the stack. Now we're back to the state of the stack when we before we called the function. Yeah, except for the parameters. We didn't talk too much about parameters. Like technically, the stack frame is restored. We're back in the function, so it's clean in that sense that we're back in the caller's stack. Yeah.
I understand what we're doing for the final information we learned, but for the other 40% of the final exam, what's
Yeah.
something we should be refreshing on to restudy?
Other 40%. Okay. Other questions on new stuff from the exam? I'll do that because I'll just go into the refresher stuff. Other questions on functions? Everybody good? All right. Let's go for refresher stuff. So a lot of it is going to be similar, not exact, but content that was on the midterm. So let's look at the content for the midterm. So way back in the past, why are file systems hierarchical? What makes file systems hierarchical in the Unix world? Stuff like this, hopefully y'all remember. Directories are files, and they're just files that contain like a phone book directory that map file names to. Do you remember how the actual file is referenced by the operating system? It's not by its name, right? Names are just given by directories. Inode number, yeah, exactly. So the operating system, the kernel, allocates a unique number for each file. It's like a phone number. And then directories are just what give them names. They map names to those numbers. And that's why if you move files or delete files or rename them, those are all operations that just happen on directory files. It doesn't actually affect the contents of the file or the inode number in any way. You just are editing the directories themselves. Even for deletion, you can literally just delete it from the directory and tell the system that inode number is free, and then that it's a virtually constant time operation to do that. How do you reference parent directories? That's with ... and also like drawing file system trees. You're obviously not going to have to draw one because it's all multiple choice. But if you're given a tree, can you identify absolute paths, relative paths? Can you follow the tree to find a file given a path? Questions like that.
There's going to be a question like the last one we had. There's like the same file.
Oh, like counting the number of unique ones.
Unique file.
There could be. I didn't put one like that on there. Yeah, I didn't put that exact question on there. That was a little tricky one, I think. But there'll be questions about following file trees. Navigation, I didn't put too much on navigation, but you should definitely know like the working directory. Hopefully using Eustace, you have a little bit better understanding of these, like renaming files, I hope everyone uses tab completion now. What Unix standard utility will show you the text of a file? There's several answers, but what cat is a good one. There was one in the exam like that it seemed to trip up a lot of people. So Echo, does it take data from standard in? No. Where does it take its info from? Arguments, takes from the arguments, and then writes the standard out. What about cat? Does cat take in standard in? Well, so it takes from arguments. If you don't give it any arguments, it will take it from standard in. Let's see. Using pipes. So how can you say pipe, or how can you say, using find and WC, how do you count all the files in a specific directory? You just say find and then use pipe. What does pipe do? Or what is the pipe in Bash? What does pipe do? Strings them together. How? What does it do under the hood?
Output of one is the input of another.
Exactly, yeah. It creates an in-memory buffer called a pipe and redirects the left command's output to that pipe and then redirects the right command's input from that pipe. And what's the syscall to create a in-memory pipe? The syscall for it? It's pipe. Yeah, it's just pipe. It's pipe for it. What does grep do? Anybody remember grep? Say again?
Lists all the files in the directory.
That's find, or ls.
It locates with the word, right?
Yeah, it'll look up strings in standard in or in a file. So grep is the matching one. I don't know if it helps you, but REP stands for regular expressions. I think it's global regular expressions. If you might, I don't know if you learned about those yet. Maybe in discrete too, you learned about those. I don't know. Changing the working directory, that's CD, or CHDIR is the syscall for doing that. Deleting files, that's RM. Implementation of delete, we talked about this. You just delete it from the directory file. Oh yeah, syscalls versus library calls. So when doing like open, read, and write, what are the syscalls for open, read, and write versus the C library calls for those? So is open a C library call or a syscall? Syscall, what's the C library call for that? fopen, right? fopen. Fopen is not the syscall. It's calling into a library, and then under the hood, that's calling open at the syscall level. And that's true for write as well. That's file syscalls. The version control. So what's like the standard or the simple workflow I gave you guys for submitting, submitting your work via Git?
What do you mean? Like the order?
Yeah, like the commands you run in Git in order to, make a commit, get it to the, git add,
Commit.
git add, git commit, and then git push to synchronize it to the, so add, you have the staging area, you have those four components of Git, you have the working tree, staging area, local repository, remote repository. Git add goes to the staging area, git commit goes to the local repository, git push goes to the remote repository, and pull goes from remote repository to local repository. Let me see, I don't have a lot of questions on this, but yeah.
Is it gonna be a question like for Git? That was like a weird one last time, like the Git log. That's not one we use all the time.
I don't. I'm not going to ask. Well, so there may be in answers. There may be ones, but I'm not going to ask you to know about. Well, yeah. I mean, I'm going to ask you to know about commands that we used in class, that we used regularly in class. Yeah.
Are we supposed to use like Git log regularly?
I mean, I use it all the time just to see if I've submitted stuff. It's useful to use it so you can see the latest commits, but I don't know how much. I'm not going to say whether I'm exactly going to. I mean, I'm not going to ask exactly, hey, use git log, but you should be aware of what it does. Because we did cover it. I mean, briefly, but we covered it in the VC exercise if you went through that.
Yeah.
But it just so what does git log do?
Shows the history of.
Yeah, it just shows the log, the history of your commits. Yeah. Yeah, that's all it does. So it's not doing any change, not making any changes to any repository or staging area. So I think we did file syscalls. Let me see if there's anything else. Yeah, C library functions versus syscalls, directories. Pipes, processes, pipes, and syscalls. So you're not going to actually have to write code for this because it's all multiple choice. But yeah, I guess the main syscalls we used for processes. How do you create a new process in the Unix world? What syscall do you use? Fork. Good. Yeah, fork. And how do you run a new program in the Unix world?
Dupe?
Not dupe. What does dupe do? For redirection, right? Dupe's for redirection. Dupe is used for redirection. It'll mess with the file descriptors. You can replace a file descriptor with a different file descriptor. So what syscall or calls can you use to run a new program in the Unix world? What's that? Yeah, so does exec create a new process or doesn't it create a new process? No, it doesn't, right? So fork creates a new process and then exec. If you run exec in your current process, what happens to the currently running program?
It replaces it, right?
It's replaced, yeah. So that text segment is gone, or at least not accessible to your process anymore, and then it's been replaced. It just literally loads that .o file or that machine code into memory from the executable file, and then just branches to the start of that.
So dupe, if I run dupe on a process, it will like branch out a new process.
That's fork. Fork is what creates a new process.
So dupe redirects to a process.
Yeah, dupe. Yeah, dupe. That's. I can see why you could say so. So fork does literally duplicate a process, but it's called fork.
Yeah. And so
Dupe is for duplicating a file descriptor.
Okay.
That's why it's used for redirection, because you can open a file and then replace standard in or standard out or other file descriptors. But that's what we used it in class.
Oh, yeah.
You can open a file and then call dupe to replace an existing file descriptor like standard in or standard out.
Wow.
Yeah.
Yeah.
So while fork does literally duplicate the process, dupe is not the syscall for it.
Yeah.
It's called fork. But that's the naming scheme given by the, AT&T guys who designed this system. All right, we talked about pipe. Opening files is open. Redirecting from standard output, yeah, that's using dupe. Dupe 2 is the easy way to do that. Let's see if there's anything else. Redirecting. Yeah, I think that covers all of the pre-midterm stuff. Other questions on content of the exam, logistics, end of semester stuff, cogen? Everybody ready for the exam? So it's all multiple choice this time, which hopefully will be a little easier on you guys and easier on my GTAs. But it's 32 questions, whatever that is, 120 minutes divided by 32. So 3.75 minutes per question, but they're all same points, but different difficulty. So yeah, that's the final exam. Let me know if you have any questions after this. I will have office hours after this. But yeah, have a good break, everybody.